So I'll go through asyncio, but since it's a lightning talk, it's going to be really fast, and it's going to be lightning fast. So in the end, if you want to go back to the code, let me know. I'll also be posting this somewhere, I guess, sending it to Draw or whatever. All of the code there is copied basically from one file, so we can go through it later by yourself, but it's basically just kind of a quick run through of the benefits. So asyncio is a library to write concurrent code using the async await syntax. It's part of the Python standard library. And why would you use it? Because CPython is single-threaded because of global interpreter lock. The key part of asyncio name is the IO part. So you're going to be using it for IO bound and high-level structured network code. That's where it basically gives you the most benefits. The code that I'm going to go through is basically just an example of where the benefits are. So the test function is passed the list of the top 500 domains from moz.com. I just needed the list of domains to show the network, to show the benefits of the network calls. The fake fetch will wait 200 milliseconds and then return. Sounds about right when you do the real thing. And the fake process, so something that's going to process the response is just going to return the uppercase of the URL. We're not doing anything with it. It's just so that we have something there, because usually you won't just return, like fetch and do nothing with it. You also want to be using Python 3.7 plus because the new asyncio run is available from 3.7 on, and it makes using asyncio from synchronous code much easier. So, all right, measuring, just a simple timer function. There's a bunch of them around, doesn't really matter. Boilerplate code, the process function, the test function that is going to be showing the times. Basically just runs the function, and the response to kind of mimic the response of requests. Package loading URLs with CSV. The file attached is downloadable from moz.com, top 500. And when you do that, when you go through the 500 URLs, because you wait 200 milliseconds, you're obviously going to get about 100 seconds of time if you do it serially. So basically request, wait for the response, and then request the next one. When you do it in async, what you're going to do is create a task and do an asyncio run of the task. But if you're doing the same thing as you did before, you're still basically synchronously doing something. So this is not really async. What you want to do is go parallel. So what you do is run all the asyncfetch methods at once, and then wait for the responses all together, and then process them however you like. So when you do that, what you do is you can do it in different ways. You can do it with the process pool executor, which gives you basically about 25 seconds. Obviously depends on the computer you have and the processes you set up. I'm just using defaults to show a point. The next step is thread pool executor. This will give you more threads on, say, older Pythons, newer Pythons. 3.8 plus will give you less threads by default. But say you get 5 seconds to get the 500 URLs. But if you actually go full async, so you use a function that actually doesn't burn Python time when it's waiting, you actually end up using 0.0 second. Wow, right? And now for the real deal, I also obviously made some requests to actual domains. It's wise to add some headers, because otherwise, if you're sending us requests, the domains will give you shit responses. again, request serial. This is actually the actual URLs. So the fetch now actually fetches with requests. It gives you 135 seconds. Request threaded is way better. You only waste 10 seconds on loading this, and some of this is due to timeouts in the sites, because a bunch of important sites are actually just data storage sites. If you go through with AIO HTTP requests, which mimics requests, you basically get the timeout time as the maximum, as the time of the processing. So it goes really, really fast. There you go, 5 minutes.
Okay, thank you. So questions? Comments? Comment from Jure. Clap, clap.
Say, how fast is this if you do this in a different thing from Python, like anything else that isn't like Python?
I mean, if the basic problem is always going to be the response times, and the question here, that's why I went through process, thread, and full async. It's always basically just the limitation. How many processes can you do? How many threads can you do? There was a talk, I don't know, maybe a year and a half ago, or 2 years, even 2 years ago, Python Meetup, where somebody was explaining that they were doing it with threads, and they were obviously like, if you're doing hundreds and hundreds of domains, you're going to be hitting the thread limit, and if you set up the thread count too high, the whole machine is going to start stopping, and you're basically hitting less limits if you're not waiting, if you're just waiting for interrupts. So then you get to the level of that, like, yeah, just waiting for the network to happen. As you saw, like the time with asyncio that Python spent in is basically 0.1 second, something like that. So it's not going to change much. The 3 seconds there is basically the timeout. So yeah, if the thing I think is the most important part. Yeah. So the most important part of this is where are you? Is this. So it's the async task parallel. So it used to be, before Python 3.7, it was quite annoying because you had to set up the loop and make sure you start it and make sure you end it when you're finished. But this now actually means that even if you're on a web page that's completely sync code, you can do an asyncio run and fetch, I don't know, 5 images from outside sources or whatever, 5 pieces of information that you have to fetch over the network. And when you're done, you have all 5. And they're going to be properly parallel instead of kind of parallel. Yeah, the loop is important.
Go to the slide with concurrent package.
This
25 seconds. Okay, so it's not that fast.
Yeah, I mean, this is actually because so just a sec. Let me see what it's basically the 25 seconds is basically because of the number of processes you get. You can use more, but using too many processes on a machine might kill the machine. So the difference between process pool executor and thread pool executor isn't really that big. It's basically the overhead of creating a process versus the overhead of creating a thread. Mm-hmm. The difference in times here is because when you do process pool executor, you get less workers.
Of course, you can, because you have more threads per core, right? Then
yeah. So version 3.7 will give you the number of processors on the machine multiplied by 5. Assuming that thread pool executor is often used to overlap I/O instead of CPU work, which is kind of a problem if you're using thread pool executor to say, hash passwords. So that's why in 3.8 the default now is OS CPU count plus 4, min of with 32. So yeah, kind of depends what kind of machine you're running and what you're actually doing in it. Yeah, it's interesting because like in sync code, what you do is use network, like use IO operations to run them in async IO in separate threads, while in async frameworks, what you're going to do is run sync operations in threads, because otherwise you're blocking everybody else. So that's the first thing that you have to do basically when you're doing a something in an asynchronous framework. You're going to have a password hasher that uses thread pool executor so that you don't bog everybody down when you're doing hash calculations. What's the first mistake that people usually do? It's actually much easier now. So let me. Oh, so this one, the line f append async fetch URL basically means you're running the async fetch, which is an awaitable. And the only there's not a lot of things you can do with awaitable with an awaitable before Python starts warning you that you didn't await it. My first setup of this code was actually attaching it to a dictionary that had the URL as a key, and then Python starts bitching about, hey, you're not awaiting this. I'm going to await it in the next line, don't worry. So yeah, you can attach them to lists, but more or less anything else, Python is going to start bitching that you forgot to await something, and that's the big problem. Like that, it's the biggest issue when you start doing async. In previous, when Tornado started, it was on Python 2.7, and you had to do yields. And it was totally easy to not do a yield, and then everything would break, and you'd go like, okay, what the fuck? Why is nothing happening? And if you're lucky, you actually return something, and you see, hey, future does not have this property. Of course it doesn't, because I was supposed to yield it. But it's with the async await, it's actually much easier. So it's much harder to shoot yourself in the foot immediately. I've found that one function in my program is async. Suddenly, many of them have to be async. Yes, yes,
yeah,
that is
by design.
Yes, that is that was again. I think it's getting much better now. But yeah, in Tornado, we basically sooner or later you have everything that's doing, like everything is async, and it's not really all that fast. I mean, it's great if you're fetching, say, one object. It's totally not great if you're fetching thousands and you have awaits everywhere, because awaits might take time, and so the times become less predictable, and it's really, really annoying. So yeah, I think the big problem with async is that you need to switch into kind of an async programming mode when you're doing it. But yeah, I agree. It's sort of like GPL takes over everything. How many threads do you need to kill a machine? Well, you have as much processing time as you have as your processor can do, and when you're over that, it basically everything starts stopping. I don't remember what those guys were saying, but it was for them. I think at that talk it was like maybe a few hundred. You have a few hundred waiting, and then switching between them becomes very expensive, and then everything goes to hell. Yeah. Yes, yes. So yeah, it's easiest. The easiest way is to test and basically write a say a hasher that does some processing operations, and you'll see that you'll run out of them really fast. If you want to do proper network I/O, just take Moz 500 and start doing head requests. There's only about maybe 15 domains that will give you a non-200 response. So, anybody else?
Can you answer the Docker part too? Sorry, the virtual machine part.
Virtual machine. What do you mean by virtual machine part? How many threads do you need to kill them? Does the limit go up if you divide the threads between virtual machines? It shouldn't. I mean, you have as much processing time as you have. Interesting question.
Let me explain the question a bit. The hypothetical solution with virtual machines is based on, like, does the Linux kernel have some upper limit when it gets too many threads and it gets confused? Like, if virtual machines would somehow alleviate that problem?
I have no idea. I've never. I think this was probably my first time. The first time I actually created a few hundred threads. Like when you're working in an async framework, you basically have one process running for everything, and the number of threads, external threads you're running, basically is related to sync stuff, where you have where you're actually using the processor. So I have no idea. Maybe it might be that Stack Overflow knows if you're looking at Tornado, because a bunch of people use Tornado at the beginning to basically write simple scrapers and like fetchers of online data, basically, not scrapers. Yeah. Does anybody know if that would help? Anybody in the crowd? I guess not. Large CPU caches help with the throughput, but you can still make the machine grind if you bring up enough threads that you're trying to handle many events simultaneously. Yeah, I think basically at the lowest level, it's just going to be you're going to be loading on switching between threads or processes or whatever, and yeah.
Don't forget about Nate's. How complex does the task need to grow? Say you need retries, monitoring, result storage, until it makes sense to use a background processing tool such as Celery.
Well, yeah, I mean, it's like if I was doing a if I was doing something like this, I wouldn't use asyncio to download 500 things and then do something synchronous on every item. It makes more sense to use a dedicated kind of queue plus worker. But it does sound like sometimes when you're doing stuff where you're basically maybe fetching 3 things and you need them all at once, it just doesn't make sense to wait for each one. And yeah, I mean, I've used the same code, so async code for workers as well on a project. I don't even remember what it was, where I'd be monitoring how many people actually, or how many people or how many resources you need. And if you were needing, if you needed just a few, I'd run the code directly. Otherwise, I'd say, okay, offload this to Redis queue, and then you'd have the worker basically doing the same thing, using the same code, fetching and resolving stuff. I mean, if you're going to be doing a lot of synchronous stuff afterwards, it doesn't make much sense, because then you'll be, when you're going to be waiting for events because you're doing synchronous stuff. So yeah, it's I guess it's a different mentality, but I think the takeaway here is that it's gotten much easier to use it just in between of your in your sync programs when you need stuff like that. Like, even if you're fetching stuff from the database, if you're going to be fetching three things or inserting 5 things or whatever into different parts of your system, you might want to just like run an async, run it in async and do everything and wait for all the results. Yeah, we did that with some success at Cube Sensors, where your base station would be sending us a bunch of sensoring information, and you need to insert all of that. Looking for where are we? Celery also needs async. Yeah, I mean, maybe maybe just to make sure that you have the same code running in 2 systems, but otherwise, I mean, yeah, it would cost a lot less. But since I think Celery still sets up the worker, no, it doesn't. The Celery have the same worker doing a bunch of stuff, right? So yeah, in that case, async would help if it was actually downloading stuff from the network. I don't know. Maybe you actually the benefit here is actually to have a separate async worker that's basically just doing I/O, and then a separate worker that's doing the processing.
Like a microservice.
Yeah. Yeah. I mean, when you switch to an async framework, like, I don't know, Tornado, or there's a bunch of them now that are pure async I/O. What you get, like, what happens is basically you gain another single process, and as long as you're running the service on your machine, you don't need anything else, because it comes with an HTTP server. And if you need, and if you hate the overhead of HTTP, you can set up WebSockets. Everything's in there already, and you basically just have one item that you need to make sure that is running. You don't need any kind of advanced like setting up of Nginx or whatever to handle the load or whatever. So yeah, it is actually good for microservices. Anybody else? Anything else?
Yeah, maybe just like a follow-up to Dror's question, where he pointed out the fact that when you start doing async, then the design kind of forces you to make all your functions async. So how do you usually deal with that? Like with the communication between, if you wanted to make an synchronous and asynchronous part of your code, and yeah.
I mean,
how do you like architecturally manage that?
There's a I think one of the problems is that we keep designing things so that basically requesting the data and processing the data is tied together too much. There's a manifest, I think it's called Sense.io, which is basically, hey, do libraries so that we can change the I/O part and do the processing separately. And in some libraries that are close to that, it's really easy. I mean, when we started out, I basically had to update, change, or fix all of the libraries that for third-party services that we used. I had to change Spark Post because they were using requests. I had to change, what was it? Raven actually had, Sentry had a Tornado implementation, but it was for an old Tornado. So yeah, if you set it up right, it's basically you do async fetching of stuff, and then all the processing can be sync still. So you don't need functions. The problem is that if your fetching function is like 4 levels down, then all of the parent functions are going to have to be async, and then you're fucked.
Yeah.
So what you do is basically you turn it around and make sure that you fetch separately, and then when you have stuff, you throw it in into kind of a pipeline of processing. Yeah, it's kind of annoying because you think when you come from synchronous, you don't think that you're going to need that, and then you have a bunch of code and you're thinking the same way. So yeah.
Yeah. Yeah, that was also going to be my question. Like, how do you gain more? Because we said in the chat in the beginning that async is a state of mind. Like, how do you get yourself into that?
Is it Sense.io? Nope. Maybe it was Sense.io and here you go. Sense-io read docs.io. How do you get yourself into an async state of mind? It's not trivial. So the synchronous way of processing is usually set up a thread, throw it a request, do all the processing, kill the thread. And async libraries will be one process that's running all the time. And it's easy to fuck it up because you save something on the wrong place and it pops up in a different response. So yeah, kind of not really trivial. But yeah, I don't know. I mean, I built in my after Cube Sensors downtime, I extracted the core of what we use there as a kind of a framework, which I guess somewhat mimics JavaScript, some JavaScript frameworks, because like JavaScript has the same problems. So you're gonna still have like a bunch of events flying around and asynchronous calls to network and all that. But yeah, it's still it's a different mentality, I guess.
Yeah, like you have to build intuition or something.
Yeah. I mean, I don't know. It's not that hard to switch at the beginning, but then when you're doing it for a while, you start seeing different options to how you could do stuff. So comment from Sterna, the problem is that once you're doing things async, it's very easy to get pulled into doing things async that really make no sense being async, which is totally true. There was a whole debate about whether you should whether you should use an async library to query Redis, and I don't think that makes much sense for like the common use. It's like using async to do memcache. I mean, you're losing more than you're gaining, because it's supposed to be fast. It's supposed to be in memory. So yeah, but on the other hand, you can also get caught in, okay, I'll just process these 1,000 elements and I'm going to do everything synchronously so that it's going to be fast. And you basically log the thread for 1 second for everybody, or 20 seconds in my case. Yeah. Yeah, Dror. Yeah, Redis is supposed to be instant unless you're doing kind of advanced calculations on it. But then you usually what you want to do is have 2 separate ways to talk to Redis. One for basically in memory, like memory cache, and the other for doing proper operations. In async frameworks, Redis and Memcache make less sense until you're actually running multiple servers, because you're always going to have an application that is across requests, so you can like cache stuff there. Makes sense as soon as you start using multiple servers, as I said. What color is your function? Let me see.
Yeah, that's like, I really like this article because it's like it's not language specific, but I mean, when you read it, you see it's probably about Python as well as JavaScript. That's like the color is like a metaphor for async. So red functions can only call red functions, and blue functions can call blue functions, blah, blah, blah. And that really makes it sound ridiculous, which is the point, I guess.
Yeah, but I mean, it's not really that complicated. I mean, as when you make sure that your async, when your IO stuff is separate, you don't have that problem anymore. You can have all of the, like most of the code can still be sync. But yeah, it may, I mean,
yeah,
for deep code, you're always going to want to actually leave it somewhat async so that you can add stops. I mean, one of the issues we had with cube sensors was we had 1,000 at our endpoint. We had maybe about 2,000 devices that were connected, basically that would connect to the server. And when I was trying to switch this to full async, at the beginning we were still using like regular HTTP requests every minute. I saw that even sending pings to keep the connections alive to a few thousand devices would take about a second. So at that, when I was sending pings, nobody else could do anything in the thread. So yeah, you then start doing, okay, do a loop, and if it takes more than X amount of time, do a sleep for 0 time, which basically means just let others do work that they need to do and then come back.
You're saying that we have to think about this on an architectural like design level, and then this article is trying to convince us that this is the language's own design issue. So I guess it's
I mean, yeah,
points on both sides, I'm sure.
I mean, I think to figure out why async, what async is kind of good for, is I always go back to why Tornado was built. So it was built at Friendster or something. Was it Friendster? No, not Friendster. What was it? It was basically a site that FriendFeed, yes. So it was a site that what it does was basically aggregate all of your social networks. So when you came to the site, they needed to fetch your feeds, to fetch the list of your feeds, and then to actually go fetch your feeds. And if they use the synchronous framework, what would happen is you come to the web page and then you wait 1 second for Twitter and 1 second for LinkedIn, 1 second for Facebook, and 1 second for something else. And if any of them actually time out, you time out. Or you wait 5 seconds more because you don't want to time out always. So what they did is come up with a generator, like they didn't really come up with it, but kind of copied it from Twisted. Kind of a generator-based format of fetching stuff at the same time, so that you basically say, okay, I have the list, fetch all the 5 or 10 or whatever links at the beginning, and when you're done, like set it a timeout, and if it takes more than, I don't know, 2 seconds, return immediately. And yeah, it made the site possible. Otherwise, like before that, those kind of sites were actually doing it in JavaScript. So give people their HTML and JavaScript, and then request stuff in JavaScript. But that was soon, like that was killed very fast with cross-domain protection and all that stuff. So you couldn't do it anymore. So it was either figure out how to do it all at once or be killed. So I mean, for sites where you have widgets, for example, usually widgets are not dependent on one another. So what you would want to do in async is run all the widgets at the beginning, and they will definitely finish before you do everything else. In synchronous code, what you do is go through main content, process widgets, process everything else, and you keep waiting. So yeah, there's like when you have stuff that you can do parallel, you're going to get the benefit from async. Otherwise, it just doesn't make sense. I mean, the overhead is going to be mostly in the way of trying to think differently. You're going to lose some time, but yeah, you're not going to gain anything. Yes, they do.
Yes.
It's a black hoodie uniform for Python Meetup.
Yeah. No, we are in a gang. A Python gang.
All right.
Yeah. There's this comment from Dror also.
Yeah, the yield time.
Yeah, that's a good point.
Yeah, I mean, well, we are, most of our code is still using yields because legacy. But yeah, it's really like debugging it is fucking annoying. I'll just say that. And there's so many times when you shoot yourself in the foot with, you have everything done and you forget a coroutine decorator on a function, or you forget to yield something and everything goes to hell and you have no idea where and why and what the hell is going on. Yeah, you put a print in a function and you have no idea why it's not working. Or you put a print in and the print shows, but the code never executes because you have a yield somewhere inside, and the synchronous print prints, but the yield doesn't do anything because you're not yielding it one level up. So yeah, it gets a bit complicated. But to me, like I always kind of like the code because the code still looks completely synchronous. You just don't waste the time or the resources of waiting. Yeah, I mean, my start with async was at Cube Sensors, where, as I said, we were waiting, like we were getting hundreds of requests every minute on the minute, because devices would get information from the sensors and then send that to the servers, and then people would be waiting with their app or API to actually get that information. And at that point in time, doing 100 simultaneous requests wasn't that cheap, because that was what, about 10 years ago. So yeah, 9, I think, maybe 9. So Yeah. All right, I guess that's it.